Hello, this is Mr. Best. Welcome to Chapter 5, Homework Questions 29 through 35. Question 29. Solve the following equations for the given variable if possible. Remember to check your answers. So on question A, we have 6x squared equals 150. So we do notice that it is a quadratic, hopefully, because of the x squared. Let's see if we can isolate the x squared by dividing by 6. So if we take 150 and divide that by 6, we get 25. So x squared is equal to 25. Now we can take the square root of both sides, or we can just ask ourselves what number times itself gives us 25, and we get two solutions. We have x is equal to negative 5 and positive 5. So those are our two solutions. To check our answer, we can just plug it back into the original. 6 times negative 5 squared equals 150. And so that's 6 times 25. And that works. And if you plug in 6 times positive 5 squared, because when you square a positive or a negative, you're still going to get 25. And that is still 150 equals 150. So it checks for both of them. All right, let's move on to B. B, we have, don't see any quadratic just yet. We can combine our like terms. 4m minus 1m is 3m. So we have 3m plus 3 on the left. And then on the right, we can go ahead and distribute the 3 to get 3m plus 3. Now, right away, at this point, you hopefully recognize that the left and the right-hand side are exactly the same, which tells you something about the answer. Now, I'm going to go ahead and at least do one more step here just so we can see what actually does happen with the variable. When we subtract 3m, the variable on the left and the right go away because 3m minus 3m is 0. And so we're left with 3 equals 3. So therefore, we can't solve for m anymore if it's not there. So what does this mean? Well, 3 equals 3 is a true statement. So no matter what variable we plug in, or not, no matter what number we plug in for the variable of m, we're always going to get this true statement, which means any number would actually work. So for this one, m is going to be equal to any or all real numbers. All right, that's supposed to be an A. Okay, and then we move on to C. And C is the square root of 5x minus 1 is equal to 3. And in terms of checking for B, since it's all real numbers, you can plug in any number and it should always check out. Now, obviously, we can't plug them all in. So in terms of checking your answers, you could plug in a couple and just verify that it is possibly all real numbers. Sorry, back on to C. So we have the square root. So to simplify this, once again, we can look at this and solve it algebraically by squaring both sides. We could also just ask ourselves the question, kind of the big picture. The square root of what gives us 3? And that would be the square root of 9. So if that's the case, we're looking inside here, and we could say that 5x minus 1 must equal 9, because that's the only number when you take the square root of it, you get 3. So like I said, there's different ways that we could look at this. The way I just did that is using the strategy we call looking inside, and then I can divide both sides by 5 and get x equals 2, and then you can check that by plugging it back in. You get the square root of 5 times 2 minus 1, and that's 10 minus 1 is 9, so the square root of 9 is 3, and that is true. And then for D, we have the quantity k minus 4 squared is equal to negative 3. We could do another looking inside. You know what squared is going to give us negative 3? That might be a little bit harder because negative 3 is not a perfect square. But the other thing you might recognize is that when you try to ask yourself what squared gives you a negative 3, is there anything that when you square it, you get a negative number? And if you recognize that right away, then you'll know that the answer is no solution. If you don't recognize that, what you're probably going to end up doing is taking the square root of both sides, and then when you do that, hopefully at that point you recognize, wait a second, I can't take the square root of negative 3, so therefore this one doesn't have any real solution. So there's no real solution to this problem. Question 30, use two different trig ratios to find the measure of angle A. Did you get the same answer both ways? I just realized that I have 31 and 30 on the same one. All right. Well, since I'm not going to go back and change it, we'll work on 30, and then we'll come back and do 31 also. So My apologies. So 530. Here we go. So here's angle A right here. We have all three sides of the triangle, and it wants to know what the measure of angle A is. So which trig ratio do you want to use? Well, we have three of them, and I'll show you all three. So first one, if I choose to use sine of A, that would be opposite side, which is 12 over hypotenuse of 13. If I choose to use cosine of A, I have the adjacent side as well, so that's 5 over the hypotenuse of 13. Or I can choose to use tangent of A, which is opposite over adjacent. So any one of those you could use to be able to solve for angle A. And then now to solve each of these, we have to use the inverse of sine, cosine, and tangent. So remember from the lesson, the inverse of sine is written this way. It looks like a -1 is a power, but it's inverse of sine of 12 over 13. And then that's what is equal to A. So that's what you would solve. If you were using cosine, you would use the inverse of cosine of 5/13. And then that would be equal to A. Or if you're doing tangent, it's the inverse of tangent of 12 over 5. And that is equal to A. So it says use two different ones. I'm just showing you all three. And then when you plug, and it doesn't matter which one you plug in, but when if you use an inverse of sine, you'll do 12 divided by 13 when you press the inverse of sine button, and you'll get an approximation for that angle measure. And so when I plugged it in, I had A was approximately 67.4 degrees, and make sure you label degrees. And then when you do cosine, the inverse of cosine, you'll get A is approximately, same thing, exactly the same numbers too, 67.4 degrees. And the inverse of tangent, once again, is approximately angle A, 67.4 degrees. So any of those three that you can use to find the measure of angle A. Now, let's move on to the next question. All right, question 31. Just move it down here. Mervin and Leela are in bumper cars. They are at opposite ends of a 100-meter track heading toward each other. If Mervin moves at a rate of 5.5 meters per second and Leela moves at a rate of 3.2 meters per second, how long does it take for them to collide? All right, let's get a little picture maybe to help us see what's happening here. So we have 100 meters, so this is 0. And then over here would be 100. We have Mervin starting at 0 and Leela starting at 100 meters. They're heading towards each other. Leela is traveling 3.2 meters per second. Mervin is traveling at 5.5 meters per second. So if we write the equation for Mervin, we have, we'll just use y as our distance. So y is equal to, and let me go back here a second. Let's do a let statement. Let y equal, and we're going to say the position because we're only looking from 0 to 100. And then we'll let, we'll just use t for time. Let t equal the time that it's going to take in seconds, and then the position will be in meters. And so now when we set it up, we have Mervin will be going y equals, and he's starting at time 0, so he's traveling at 5.5 meters per second, so that'll be 5.5 times t, but starting at position 0, so that'll just be plus 0. Whereas Leela is y equals traveling at 3.2 meters per second, but she's heading in the opposite direction. So we do want to use negative 3.2 meters per second times time. And then once again, though, her position is at 100, not at 0. And so if we want to figure out when that position is going to be the same, we can solve this system of equation. And we can use the equal value method and set these two equal to each other. And then solve for time. So we can add 3.2 to 5.5, and that'll be 8.7. So 8.7t will be equal to 100. And then you can divide both sides by 8.7. So 100 divided by 8.7 is approximately 11.5 seconds. and then make sure you do answer the question. So this is for question 31. Question 32. Assume that 2 standard dice are being rolled. Event A is equal to the sum is a multiple of 3, and event B is equal to the sum is a multiple of 4. The probability of event A is 12 out of 36, and the probability of event B is 9 out of 36. Question A, how many outcomes are there in the intersection of events A and B? So the intersection, remember, means that happens in both. So maybe to dive into this a little bit deeper, we need to know, what are the possibilities. So if you roll, once again, 2 standard dice, think about the possibilities that you could have. You could roll 2 ones. That means the sum would be 2. You could roll a 1 and a 2, and the sum would be a 3. So I'm just going to continue this pattern out until I find all the different sums, and then that way we can answer the question correctly. So now that I've listed out all 36 possibilities, took a couple minutes to do so, but there they all are. And where are the sum for multiples of 3? So 3, 6, so 3, 6. Then we have 6 and 9. 6 and 9, 3, 6, 9, and then 12, so 9 and 12. So you can see each group has 2 that have multiples of 3. So that'd be 2, 4, 6, 8, 10, 12 possibilities. And that's why you see 12 out of 36 up there. But here's the next thing. Now we want to look for the intersection, so we also want the multiples of 4. So now we have 4 and 8. 4 and 8. 4 and 8. No more 4s there, but there's an 8. There's an 8. And then we also have 12 possibility. And right there, I don't want to overlap it too much, but right there you can see that out of all of these, that was the first time that I overlapped. And we should have 9 green dots. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's 9 out of 36 up there. So if we get back to question A, how many outcomes are in the intersection of events A and B? There's only one. Probably don't need to write as a highlighter here. Sorry about that. There's only one outcome in terms of the intersection of multiples of 3 and 4 when you're dealing with the sum of 2 dice. So now let's move on to B. What is the probability of A or B happening? Now remember, A or B, we already have A is 12 out of 36. We just found B also is 9 out of 36, and those two were given. But we had one overlap at 6. So we also have to subtract 1 out of 36 with that overlap. And now when we add those all up, we're going to get 12 plus 9 is 21 minus 1 is 20. So 20 out of 36 is the probability that we could roll event A or event B. Question 33. Find the area and the perimeter of the figure below. Be sure to organize your work so that you can explain your method later. So the perimeter, we have 16, 18, 24, and then we're missing the other 2 side links. We could break this up into maybe a smaller triangle right here. We know that's 20 degrees. If this is 18 and this whole thing is 24, then that means this piece from here to here has to be 18. So therefore, this would have to be 6. So we do know a part of that triangle. We can use our trig ratios to figure out the other links that we need to, and probably really need to focus on this length right here. We also know that if we find this length down here, then we can figure out this other length because we know it has to total 16. So we've got a little bit of work here to do. Let's go ahead and get started on the triangle. Let's go ahead, we'll call the hypotenuse H, and let's use our trig ratio. So let's start with x. If we know this side right here, that would be the adjacent side, and we're looking for the side opposite that. Okay, so which one uses adjacent and opposite? That will be tangent. So we'll do tangent of 20 degrees is equal to the opposite side, which is x, over the adjacent side of 6. And then we can multiply by 6. So x would be equal to 6 times tangent of 20 degrees. So that's the exact value. Let's plug that into the calculator. Make sure your calculator is in degrees. And when you take 6 times tangent of 20, you will get approximately we'll go to the nearest hundredth, 2.18. That would be in meters. So we don't need that x for the perimeter, but we now can use this, knowing that this is approximately 2.18. If we take 16 minus 2.18, we'll get 13.82. So that will help us with the perimeter. 13.82 would be that length. Let's go ahead and find the h value now. We'll go ahead and stick with the 20 degrees and this adjacent side. So which one uses adjacent and hypotenuse? And that would be cosine. So we'll do cosine of 20 degrees is equal to the adjacent side over the hypotenuse. And then we'll solve for h. So multiply by h, we get h times cosine of 20 degrees is equal to 6. And then we can divide both sides by cosine of 20 degrees. So the exact answer is 6 divided by cosine of 20 degrees. And therefore, let's go ahead and get the approximation. So 6 divided by cosine of 20 will be approximately 6.39 meters. So now we know this side length is approximately 6.39. So to find the perimeter, we'll just add up all the sides. Start with the bottom, 16 plus 18 plus 13.82 plus 6.39 plus, and we'll go the full length, 24. So we won't worry about that 6 because it's 6 plus 18. That gives us the full length of 24. And then if we add that up, what do we get? 78.21 meters. Don't forget a label. There's the perimeter. Now let's get back to the area. We have all the information, we just need to put everything together. So we'll take the area of first the rectangle, and that'll be 18 as one length times 16, so that'll be the area of the rectangle. And then we also need to find the area of the, so this will be of the rectangle, and then we'll do the triangle. And the triangle would be 1/2 base, and we'll use this as our base down here, the x value, which was approximately 2.18, times the height, which would be 6. And then we'll take those two values and we'll combine them. So 18 times 16 is 288. That's for the rectangle. For the triangle, it's going to be approximately, because we had to find the side of 2.18 approximately. So let's see what we get there. So I got 6.54. And then if we add that to the 288, we should get 294.54. So here we go. So the area, the total area, is 294.54. Now I got 5.4, and the book looks like it got 5.5, and that might just be because of the rounded. The 2.18 is a rounded answer. They might have used the exact answer. So make sure we put meters squared on the area there. Question 34. Jerry was trying to use a flowchart to describe his friend Marcy feels about Whiz Bang's candy. Examine his flowchart below. How do you know Jerry's flowchart is incorrect? Well, let's look at the flowchart. So we have, I don't know really which one to start with because it just goes around in a circle. If I start with this one, it says Marcy likes chocolate. Then that goes to Whiz Bangs are 100% chocolate. And then that one goes to Marcy likes Whiz Bangs. Back to Marcy likes chocolate. And it just kind of keeps going around. So we know it's incorrect because it's a circular logic or a circular motion. It just kind of keeps repeating itself. So question B says, make a flowchart on your paper with the same 3 ovals, but with arrows drawn in so the flowchart makes sense. Explain why your flowchart makes more sense than the one below. So I went ahead and set up the flowchart the way that it would make sense if we said Marcy likes chocolate, and then the Whiz Bangs are 100% chocolate. If that's true, then those would both go to, we know that Marcy's going to like Whiz Bangs because they're 100% chocolate and she likes chocolate. Question 35. While playing a board game, Mimi noticed that she could roll the dice 8 times in 30 seconds. How many minutes should it take her to roll the dice 150 times? So we could set up a proportion here. If we have 8 times for every 30 seconds, the question now is, If she rolls it 150 times, how long would it take? So we'll do the time over the number of rolls over the time, and then we can just cross multiply and solve for the time. So we'll get 8t is equal to 4,500, and then we can divide both sides by 8. And we get the time to be 562.5, and this would be in seconds. But the question says how many minutes should it take? So if we're at 562.5 seconds and we want to convert that to minutes, we can use our conversion for seconds and minutes, and that's 60 seconds in 1 minute. And so we end up dividing by 60, and that will give us 9.375 minutes.